So okay, let us start. We are dealing with a problem for Kosla's theory, right? We are doing that, so we'll complete that particular problem. So this was the problem. This was your typical concrete wire that was given to you. This was the typical concrete wire that was given to you. Your every data are given, you can see that. So from that you have to find out what you have to find out: the exit gradient that is given by this formula, the exit gradient, and the pressure is at the particular pressure points as described by Khosla, right? You have to find out those. So firstly, what was done? We have found out that we have disintegrated the complete structure, like for Khosla's theory. We have disintegrated the complete structure into three simple profiles. Then we have evaluated each of those profiles, and after that, at the end, what we have done the corrections that were needed. There were three such corrections. One was for the influence of the other piles, another one was for the thickness of the floor, and the last one was for the slope. Because you can see this is not a horizontal kind of thing. It has a slope in the middle. It has a slope, upward slope, then a downward slope, right? So this needs to be tackled out. So for the first part, we have seen that for these piles, for this specifically for this pile, the pressure heads at these particular points have been found out, right? Considering the floor to be a negligible thickness, means what Khosla did, he just considered for the first profile, he considered the floor to be of negligible thickness and with the end pile, right? So this is your end pile. Sorry, this is your end pile. So the floor, only the top fiber of the floor was considered for evaluation. So this is the top fiber of the floor. Okay. So he found out the pressures at these particular points, this point and this point. But actually you need to find out the pressure at these particular points, right? So firstly, for these 2 points, the formulas were given like this. When you calculate that B by D, B is the total floor length, D is the depth of the cutoff pile. The depth is, you have to consider for the first case, you have to consider the depth from the top fiber itself, not from the 1 meter thickness floor. Okay, you have to consider it from the top fiber. So the top fiber, it has a reduced level of 154, right? You can see that it has a reduced level of 154, and at the end it has a reduced level of 148. So what is the height? That is 154 minus 148. That will be the depth of the pile. Always remember, for the first case, when you are considering the floor thickness to be negligible, then only you have to consider the depth of the pile from the top fiber of your floor to the end of your pile, right? For that case only you have to consider this thing. Otherwise, when we will be doing the corrections and all those stuff, at that moment we have to consider the depth of the pile. Suppose for this particular pile, you have to consider it from the bottom of your floor. Okay, always remember that. For the when you are considering the negligible thickness, we will be considering from the top fiber, and for the corrections and all, we will be considering the depth of the pile from the bottom fiber. Okay, we will see while doing this problem, we will be getting a better idea of it. Okay, so your D value comes out to be 6. You can understand from the top fiber it is 6. Okay, so B by D has been found out, and from that alpha, so alpha equal to B by D, you can directly get it from the formulas like this, where lambda is given in terms of alpha, and phi D, phi E, these values you can find out, right? This you can find out as because you know the value of alpha. So you can find out the value of lambda, and similarly from that phi E and phi D can be found out, and from that you can easily get the value of phi C1 and phi D1. So this is the formula based approach of it. Okay, so, and you already know at the extreme points there has been mentioned in the question that there is no flow on the downstream. So at this point it will be 100 because there is no loss here, and at this point it will be 0. These two are already known to us, right? So for this part, if you do the mathematical analysis of it, you can find out the value of these two values, that is this value, not this value. Actually this is not being found out because you are considering the floor thickness to be negligible. So this value has been found out, right? So this and these two has been found out from this. So you can do the mathematical approach, or also you can do it from the graph. For the graph, there is a graph. I don't know how much you will be able to understand because of the, if you don't see the graph, I don't think there will be a clearer vision of it. But anyways, if you find out the graph, if you look at the graph, you can be easily able to understand that this this axis represents 1 by alpha. Okay, this axis represents 1 by alpha, and these are the graphs. This is the graph for phi e, and this is the graph for phi d. Okay, so these are the graphs. This you need not to concentrate on this, just leave this one out. So what is being done, this axis represents 1 by alpha, so 1 by alpha turns out to be your 0.105. okay, so from you have to pick that point from this. So this is the point, suppose this is 0.105. okay, so from that you have to draw a perpendicular from these two graphs, that is this graph and this graph. You have to draw perpendiculars. Okay, then at the point it intersects the graph, from that you have to draw a horizontal, and that value will give us the value of phi d and phi e. Okay, for this graph, as this is phi d, this will correspond to your value of phi d. You can see that vertical has been drawn like this. Okay, and from that it intersects the curve at this point, and a horizontal from this point has been drawn. So this value, this turns out to be 20. So 20 is the value of phi d. Similarly, at the from this point vertical has been drawn to this curve, and a horizontal from this point has been extrapolated, and this turns out to be 29 from the graph. Okay, so your this is 29. Okay, so what is the value of 29? Phi e. As because you are getting this value adjacent to your phi e graph, this phi e will be your 29. So phi c1 will be 100 minus 29, that is 71, and phi d1 will be 100 minus 20, that is 80. Okay, so this is the way how you can tackle it from the graph. Just hold on. Okay, so this is the way how you will be able to tackle from the graph, or also you can do it by this mathematical formulas. If you will be provided with the graph in the time of your exam, so you can directly get it from the graph. Otherwise, through calculator you will be able to get the values as well. Okay, so these are the values that have been found out. So what are the values? This point has been found out, that is phi e1. This is already 100, you need not to find it. So this is already 100, and this value is phi c1, but actually what we need the pressure out here at this point. Okay, so that is the phi c1. This is the this is not the actual phi c1 which we have calculated. We have calculated at this point, but we need the pressure percentage at this point. Okay, so there needs to be a correction, but here there won't be any correction because we have seen that we need not to do any correction out here at this particular point. Okay, so what will be the correction for phi c1? Due to the there will be two such corrections. There are in total 3 corrections. We have seen that. What are the 3 corrections? One is for the mutual interference of piles, another is thickness of floor, and slope of the floor. We can see that there is no slope, right? For this particular part there is no slope, it is horizontal. So for the third correction, that is for the slope, there will be 0 correction. we need to correct it for two things, that is, one is for the influence of this particular pipe, and the second one is for the thickness of the flow. These two needs to be corrected. These two need to be corrected. Okay, so what is the first part correction? You can see that it is given by this particular formula itself. Okay, that is 19 root over capital D by small d. It has been discussed, and you have also, if you go to the notes, you will be able to see it, into Acha, am I audible?
Yes, sir.
Okay, there are connection issues. Okay, so I think now it has been resolved. Okay, so as I was telling you, up to which portion has been covered? This correction part you have been able to see or not? Have you been able to see this correction part? Hello.
No, sir.
Okay. So these have been calculated. Okay, we have got these particular values. So then we need to do the correction because we have got the values. This one we don't need any correction. This is okay. This phi d is okay. Phi d1 in fact is okay. And this phi e1 is also okay because it is 100. But here for this phi c1 we need to do a correction because we have got the value of phi c1 at this point, which is not actually our motto. Our target is to find the value at the base of your floor, right? So at this point we need to find out the pressure, so there needs to be correction. What are those corrections? We have seen that one is for the mutual interference of pile, another one is for the slope of the floor, and last one is the thickness. So there is no slope. You can see this floor is not having any slope, so there won't be a correction in this part. The correction will be only for the thickness and for the mutual interference of this second pile. Okay, so for the second pile, what is the mutual interference? It is given by this particular formula. Okay, so where d is the depth of your influencing pile, capital D, sorry, is the depth of your influencing pile. I have told you for the correction part, only when we will be considering the thickness as negligible thing, then only we will be considering it from the top level, means the top fiber of your floor. Otherwise for the corrections and everywhere we will be considering the depth to be from the bottom of your floor. Okay, so you can understand from the depth will be from the bottom of your floor. So this is your floor, right? If you extend this, this is your floor. So what is the thickness of the floor? What is the, sorry, depth of the pile? This one, pile 2. What is the depth? For in case of considering your influence, what is the depth of this second pile? It will be from this point. So this length will give us the depth of the pile, right? What is the depth? This is at a reduced level of 154. This is 1 meter. So this is at a level of reduced level 153, right? 153, and this is 148 reduced level. So the net depth will be 153 minus 140, it will be 5. You can see that it will be 5. Okay, and for the small d part, that is the on which the effect has occurred, this for this part we will again be considering it from the bottom fiber, not from the top fiber. So here also it will be 153. This is 153 minus, here also the reduced level is 148. So it will be 153 minus 148 equal to 5. Okay, so you can see that these are two, both are 5s. Okay, b dash is the distance between the two piles. This has been given. You can see that 15.8 is the distance between the two piles. So small b dash is the distance between the two piles. Small b is the total floor length. Okay, and that is given as 57. You can see from the figure itself, it is 57. So accordingly you can find out the correction value. Okay, that is 1.88%. That is the correction value. And whether you have to add or subtract, as I have told you, if your influencing pile is on the downstream side of your of the pile that is having the or bearing the effect, if your influential pile is having on is there on the downstream side, then there will be an addition, right? So this particular percentage what we have got, this will be there will be a positive correction. As you can see, there is a positive correction, the correction is positive, right? So this we have to add on to this value that we have got, to the phi C1 value that we have got. Okay, we have to add on for the influence of the pile, and another one is for the thickness of the pile, thickness of the floor. We have to correct for that also. Okay, so what is the thickness? We have to do it by unitary method. So what is done by unitary method? We know what is the value of phi d1. So what is the value of phi d1 has been calculated out to be 80. At this point it is 80. Okay, and what is the value of phi c1? That is 71. So at this point, just at the extreme point, it has been calculated as 71. So in between, this is in between, so it has to be between 80 to 71, right? So and from 71 we have to add it, because it, you can understand, from 71 as you are going down, there will be an addition, and at the end it is 80, right? From 71 it is gradually increased to 80. So anywhere between these two points, that is this point and this point, anywhere between these 2 points, that will be greater than 71 of course, and less than 80. So for 71, considering 71, we have to add on a particular value, and that is known as the correction for the thickness of the floor, and that correction will be just done by unitary method, because we know the thickness of this floor, that is 1 meter, right? We know the total this total length from the top fiber to this, that turns out to be 6. So for 6 meter length, there is a change of 81 minus 80 minus 71, there is a change of 9%, right, for 6 meter length. So what will be the change for 1 meter? 1 meter will be given by, you can understand, 9 by 6. So for that purpose we have to just add on this, what we have got, this is, this turns out to be 1.3 by 2, that means 1.5, right? So 1.5 we have to add on to your 71 value. So the net result will be, you can see that 71% plus your this correction, that is 1.88, we have calculated it from the mutual interference, and plus your 1.5, that is for the thickness correction, and the end result of that is phi c1, that is the phi c1 is the value of the pressure head at this particular point. So this turns out to be, your net result is 74.38, that is the corrected value. Okay, and there won't be any correction for phi d1. I have told you there is no correction. The only correction which will be at the base of your floor. Okay, so have everybody understood this particular part for the upstream pile? Just let me know whether you have understood or not. Yes or no?
Yes, sir.
Okay. So next part is for the intermediate pile line number 2. Okay, so for this particular part we will be doing the analysis for E2, C2 and D2. Okay, we will be doing the analysis. So this particular part, you have seen that these are given by formulas of firstly the alpha 1, alpha 2 have been found out, then from that we have found out lambda and lambda 2, lambda 1, lambda and lambda 1 have been found out, and from that we can easily get the value through mathematical approach. Like in case of this we have done this particular formula, so here also we can do the mathematical approach. You can see that d will be your 154 minus 148, for considering, I have told you, while considering the thickness to be negligible, we will be taking the length from the top fiber. So the top fiber, you have seen that it is at a reduced level of 154, right, and the bottom is at a reduced level of 148. So net will be 140 154 minus 148. So the depth of the intermediate pile is 6 meter, right? The total B is the total floor length, that turns out to be 57. So these are given in the formula. If you just have a look at the previous slides, you will be able to understand. So alpha is given by B by D, which turns out to be 9.5. Okay, and B1 B1 B2, those have been found out. So what is the value of B1? B1 is the distance of your intermediate pile from the just from the upstream end of your floor. Okay, so what is the upstream end of your floor? How can it be calculated? Just try to get the point. B1 is the distance of your intermediate pile from the upstream end of your floor. Okay, so B1 from this pile to this one is 15.8, but we have to add on this 0.6 because for this pile is located at a distance 0.6 meter from your extreme end. So we have to, as we have to calculate the value of B1 from the extreme end of your floor, so we have to calculate this part also, that is we have to add up this 0.6 value also. So 15.8 plus 0.6 will give us the value of B1. Okay, and what will be the value of B2? B2 will be the value, that is 57. The total floor length is 57. So 57 minus your B1 value will give us the B2 value. B2 is basically the distance of your intermediate pile from the extreme downstream side of the floor. Okay, so what is the distance from this point to this point? Okay, from this point, not from this pile but from the extreme end of this floor. Okay, so either you can do 40 plus 0.6, that is also correct. 40 B1 equal to B1 equal to 40 plus 0.6. This is not B1, this is B2. So B2 equal to 40 plus 0.6, or also B2 can be written as the total floor length minus B1. Total floor length is 57, that is represented by B, small b, minus your B1. Okay, in both ways the result will be the same. Okay, because 57 is right from this extreme ends, right, it is right from the extreme ends of your floor. B1 is the B is the distance. So B minus B1 will give us B2. This is B2. Okay, so B1 is this, B2 you can understand 1 minus B1 by B. So B1 and B2 have been calculated, and from that we can get the value of lambda 1. Firstly we have to get the value of alpha 1 and alpha 2. You can see that alpha 1 and alpha 2 have been calculated. From that you can easily get the value of lambda 1 and lambda. So from that then you can get the value of phi E, phi D and phi C. So phi E, phi C and phi D, you can see that these are the values that have been calculated. Also this can be drawn from the graph, but I don't think this is quite visible to you. Just leave it for now because you can do it from the formula itself. Okay, this particular graph is quite cumbersome, because if possible just have a look at the graph. Okay, the your ebook has been provided to you. If you look at the graph, like this one is quite simple, you will be able to understand because I have told you, but here there are many such graphs. You can see many lines are there. Okay, so if you have just you have the ebook, or just look in the net, if you can see this graph, you will be able to understand. Or also you can do it right from the graph also, right from the formulas also. You can easily find out these values. This is from the graph. Okay, this is from the graph, and these formulas you can get the exact values, or even you can say that from graph is not so accurate, but this through mathematics if you find out, this is more accurate. Okay, so preferably if there is an option to be able to do the problem through mathematical aspect, do it by that only, because you will be able to get the more approximate result in this case, or the exact value you will be able to get through mathematical formula. Okay, so leave it through graph, just leave it for now, because that is quite cumbersome. From this graph you won't be able to understand, because it's not quite visible also. Okay, so you can easily get the value of these particular values, right? You can easily get these values. So after that, what we need to do, we have to do the correction for this value and this value. This, there won't be any correction at the end of the, I again repeat, there won't be any correction at the depth, means at the base of your pile. At the extreme end of your pile there won't be any correction. All the correction should be at the junctions of your pile and the floor, all those corrections. Okay, so what is the what are the corrections that we need to do for phi e? Just have a look here. Okay, so phi e is the value at this particular point, right? We have found out the value at this particular point, and phi c is the value at this particular point. So actually what we need, the value at this point, that is phi e2 and phi c2, right? These two values we need. So for this part, phi e2, we have got this value, but we need to do the correction similarly for two parts. That is, there is no slope at this point, you can see there is no slope, but we need to do two corrections. What are those corrections? One is for the your thickness of the floor, and another is for the interference of this particular pile. So for this pile we have to consider, for that this pile there is a change of E2 value for this pile. For this pile there won't be a change at this point. Okay, there will be a change at the adjacent point, that is E point only. So for this particular pile there will be a change in E2 value. Okay, or phi E will be changed to phi E2. So what is that change? Similarly we have to do again this particular formula. We have seen that this is the formula. Okay, root over the capital D by small b dash into d plus small d plus capital D divided by b whole into 19. Okay, this is the formula. So here also the influential pile, you can see that it is for 153 minus 148. As I have told you have to take the distance from the bottom fiber. So both turns, the small d and capital D, both turns out to be 5. Okay, both turns out to be 5. And what is the b dash distance? That is the distance between the two piles. It will be remaining the same, that is 15.7. Okay, so the value turns out to be, the correction is 1.88. Okay, and what kind of correction this will be? You can see that the influential pile is located on the upstream side. The influential, this is the influential pile. For this particular pile, this is the influential pile. So this is located on the upstream side. Once it is located on the upstream side, we will be subtracting that correction. Okay, this means that will be a negative correction. So this will be negative. You can see that 1.88 is for this particular pile, as this is on the upstream side. This influential pile, I is denoted by influential pile. This is on the upstream side. So this particular correction will be negative in nature. Okay, next is for the thickness of the floor. Similarly we will be doing it through unitary method only, because we know this value, we know this particular value. Okay, this has also been calculated. So for 1 meter depth, what will be the value? Here we will be able to get. So here you can understand, for as this is on the upstream side, the value here turns out to be, look, it is phi c. Yes, phi c is just hold on. Yes, so phi c it comes out to be 56 and this is 63. Okay, so sorry, phi e turns out to be 70 and phi d turns out to be 63. So just look here, this will be 70, right? This have been calculated to be 70, and here at this point it will be 63. This has been calculated. So here there will be a reduction as you go down from this point to this point. There will be a reduction in the value from 70. It has been reduced to 63. So somewhere in between it will be less than 70. So that particular value needs to be subtracted. Similarly, this correction will also be negative in nature. It will be less than 70. You can understand that. Okay. So here also it will be negative in nature. So you can see that for this value there are two negatives being added on, that is 70. What has been calculated is 70 minus this is due to the influence of the upstream pile, and minus 1.17 is the influence due to the thickness of the floor. Okay, so though both have been subtracted, both are negative corrections, and the value of phi E2 comes out to be this. So phi E2 means this particular value, these have been corrected. Okay, these have already been found out. So next part is phi C2. We need to find this part also, that is phi C2. Actually we have got the value out here, and also considering the slope to be like this, right? For the slope to be like this, we have found out the value to be phi C2. It is somewhere I think calculated to be, you can see that it is 56, but there needs to be all the three corrections. One is for the thickness, another one is for the influence of this extreme downstream pile, for the downstream pile, and also for the slope of the pile. All the three considerations have to be there for considering your phi C2 value. Okay, so first part is phi C2, we have calculated phi C2. Next part is the correction. Next, what is the first correction? Considering the what will be the correction for the interference of the pile? We will be considering the downstream pile only, downstream end pile. Okay, so for this particular pile, this value will be changed. So how? So what is the value of D? What is the value of depth of this upstream for this downstream pile? What is the value? It will be considered from this base. Okay, we have to consider it from this base. Just try to get this point. We have to consider it from this, just extend, no matter how much is the slope, we have to just from the base of the floor we have to extend it. Okay, so then we have to calculate the value of D. This total length will give us the depth of the pile. Just try to get this point. This complete length will give us the value of D for this depth of the pile. Here this D value will be remaining the same. Okay, but here also we will be considering the depth to be this. Similarly, when considering this particular correcting this particular E3 value, we will be drawing, what we will be doing, we will be considering the float to be like this. Okay, from this part. Okay, so for that purpose we will be considering this part only as the depth of your influence of your middle pile. While correcting this E3 value, the value of depth of the influential pile will be this part only, not the complete depth. Have everybody got it? Just let me know. Yes or no?
Yes, sir.
ওকে, কিরে বাকিরা বুঝতে পারছিস? সুমন্ত?
হ্যাঁ স্যার বুঝতে পারছি।
হ্যাঁ, ঠিক আছে। So let's do one thing, we'll stop here. We'll be doing the corrections in the for that part, because it won't be completed in 10 minutes. Okay, so let us stop here. We'll be doing the correction in the next class for the two other piles. Okay, if you have any question you can ask me, otherwise you can leave. উপাসনা বুঝতে পেরেছিস?
হ্যাঁ স্যার বুঝতে পেরেছি।
Pooja, have you got it? Okay, so if you don't have doubt, you people can leave.
Thank you, sir.
Okay.